I'm going to go ahead and start with some introductions while we wait for other folks to join us. I'm Margaret Krome. I'm with the Michael Fields Agricultural Institute. I'm the policy director there. And this session you are in is capturing water and reducing floods. Can healthy soil save society money? We just heard a wonderful presentation and Q&A with Dr. David Montgomery around questions of what healthy soils can do for farmers and do for society in saving soil and perhaps increasing the value, the nutritive value in soils and in the food that we consume. We have begun exploring a question, and this session is the opportunity to join us in that exploration. This session frames the opportunity not to focus on on-farm benefits, though very important, but to focus on understanding more about off-farm benefits of soil health practices at the watershed scale. You probably are aware, but this session is being recorded, and you will in fact be able to get access to the recording in several days through your Whova account. I'm going to just tell you a little bit about how this next session is going to proceed. For those who came in late, I'm Margaret Krome, Policy Director at the Michael Fields Agricultural Institute. This session, the genesis of it was actually very modest. It started a couple of years ago working to try to get a piece of legislation through the Wisconsin legislature pertaining to cover crops. And we came very close to success, and then COVID hit. I began to be quite worried that we were going to find ourselves in a challenging budget situation where it was going to make sense to have been able to develop an argument around how soil health practices could save various levels of government money. And so I began exploring the question, and I hired a colleague of ours, an excellent consultant in North Carolina, Scott Marlowe, and he developed some numbers around Wisconsin. I used to notice that when we have these extreme rain events, which are increasingly they're increasing in number and ferocity and increasingly likely as predicted by models, we began to be worried that we were going to be seeing these torrential rains, and they were going to take out roads, as they have been doing, from just the water, the force of the water tearing off the land. And the question is, if you could hold that water in the soil using healthy soil health principles, could you reduce the costs of repairing the roads and the bridges and the culverts and all of the other infrastructure that floodwaters damage? That was what was of interest to me. And I began speaking with various communities starting a year and a half ago, and inviting Scott in. And what happened was we just found it was a sticky topic. More people kept wanting to join our discussion, and it grew on its own, such that we ended up last summer convening a national conversation around this. And we decided to frame this question, not just the benefits of soil health for farmers, but society at large. How about cost savings to governments? And so our idea was to create iterative discussions based on short, readable, fact-based, but non-academic papers, discussion papers. And we surveyed our participants. It was a national spread of participants. Last summer, we said, what topic should we begin this with? Talking about societal benefits to soil health, that's a broad topic. Where should we begin? And we chose, the participants collectively chose the following: how do different conservation and soil health building practices reduce the amount, especially, but also the contamination of water, leaving farm fields from storms of differing severity and timing? So it's framed around water, aiming to better understand these off-farm benefits of soil health practices and to develop strategies around them. You will notice that immediately following the break after this session, we will have a second session that is kind of a complement to this one, which is about soil health for watersheds. How can federal agencies help? And it is intended to build on the thinking and the discussion that will arise in this session. So I'm going to introduce our speakers one at a time. But first, I thought I would just give you, again, those of you who are newly joining, you haven't yet understood the way in which to express your questions. So as opposed to doing what we're mostly trained to do these days, which is put things into the chat box, you can feel free to have chats if you want, but use the Q&A box, please, if you have questions you're wanting to present to the speakers. So I'm going to I'll be handing over the job of monitoring that Q&A box to Chris Lent, who is a sustainable agriculture specialist with the National Center for Appropriate Technology. And we're grateful that you'll be helping us. Thank you, Chris. So put your questions as our speakers are presenting. After the first speaker, who is Julian Reyes, whom I will introduce in a moment, with the national USDA's climate hubs, I'm going to have a mini Q&A session there, 5 minutes. So go ahead if you have questions for clarification or a brief comment, feel free to put those in the Q&A, and we will have just a 5-minute chance to kind of recalibrate and level set before we proceed to the second speaker. And we'll do the same thing after her presentation. And then one more time after the third presenter, we will just open it up and have questions about hers plus all of them. And then we'll have a broader, but again, you'll need to do it through the Q&A box. So with that, I do want to introduce Dr. Julian Reyes. He is the National Coordinator for USDA's Climate Hubs program. And in that capacity, he provides connection and cohesion across all of the regional hubs around the country, integrating climate hub work across USDA agencies, coordinating with other climate networks, engaging with stakeholders. Previously, Dr. Reyes was a AAAS, Science and Technology Policy Fellow at the State Department in their Climate Change Office, and was also a Climate Hub Fellow with one of the individual regional hubs, the Southwest Hub. He's done many other things, but his interests broadly are in his expertise in hydroclimatology, climate change impacts in agroecosystems, and eco-hydrologic modeling. His PhD in civil engineering came from Washington State University, and he also got a BS in civil engineering at WSU. He was a Fulbright scholar in Germany. He is a really fascinating person with a perspective that we've asked him to bring before we start talking about the impact of soil health in addressing and mitigating and responding to climate change. It seemed important to hear from Dr. Reyes about what can we expect. So that's what he will jump in with. So welcome and thank you so much. We very much appreciate your thoughts.
Thanks so much for that introduction, Margaret. It's a great introduction. And I also want to say thanks to Steve for having a conversation and inviting me to this. I'm really excited to give my perspective on soil health. I'm not a soil health expert, nor am I a climate expert, but I work with, I support farmers, producers, ranchers, land managers through the Climate Hubs program. And, they are feeling the impacts of climate change right now. And so I think, through the lens of climate science and climate service, that we can provide a nice framework for the next two presentations for this session. And then hopefully giving you an idea of America's climate future, resilient agriculture, and soil health. So we all know that healthy soil is the foundation of productive, sustainable agriculture. As you heard from previous presentations, healthy soil gives us clean air and water, bountiful crops and forests, productive grazing lands, diverse wildlife, and beautiful landscapes. And soil does all of this by performing 5 essential functions. First is regulating water. Second is sustaining plant and animal life. Third is filtering and buffering pollutants. Fourth is cycling nutrients. And fifth is the physical stability and support from soil. Managing for soil health also allows producers to work with the land, not against, to reduce erosion, maximize water infiltration, improve nutrient cycling, save money on inputs, as Margaret mentioned, and ultimately improve the resiliency of their working land. And this can be done through the following principles to improve soil health, which include minimizing disturbance, maximizing soil cover, maximizing biodiversity, and maximizing the presence of living roots. An example of management activities include rotating livestock, planting cover crops, using diverse crop rotations, and reducing fallow. However, healthy soils are at risk due to climate change. These figures are from the 4th National Climate Assessment, and these show observed changes in annual average temperatures and projected changes, which will increase with proportionally greater changes that are higher as compared to lower latitudes and under a higher climate change scenario. The largest observed changes in temperature were actually in the western half of the US, where average temperature increased by more than 1.5 degrees Fahrenheit in Alaska, the Northwest, the Southwest, and also in the Northern Great Plains, essentially in this darker red in the left figure. And over the past 2 decades, the number of high temperature records recorded in the US far exceeds the number of low temperature records. The length of the frost-free season from the last freeze in spring to the first freeze of autumn has also increased for all regions since the early 1900s. Extreme high temperatures are projected to increase even more than average temperatures. Cold waves are projected to become less intense and heat waves more intense. The number of days below freezing is projected to decline, while the number of days above 90 degrees Fahrenheit is projected to rise. The bottom line is that annual average temperatures over the contiguous US have increased. An additional increase in annual average temperatures of about 2.5 Fahrenheit or 1.5 Celsius are expected over the next few decades. Annual precipitation since the beginning of the last century has increased across most of the northern and eastern United States and decreased across much of the southern and western United States. Over the coming century, significant increases are projected in winter and spring over the northern Great Plains and upper Midwest and the Northeast. Observed increases in the frequency and intensity of heavy precipitation events in most parts of the US are also projected to continue. Surface soil moisture over most of the US is likely to decrease. Significant changes in water quantity and quality are evident across the country. These changes, which are expected to persist, present an ongoing risk to coupled human and natural systems and related ecosystem services. Variable precipitation and rising temperatures are intensifying droughts, increasing heavy downpours, and reducing snowpack. More intense rainfall leads to water redistribution between surface and groundwater and catchments as water storage in the soil decreases and runoff and reservoir inflow increases. This results in increased surface flooding and soil erosion, increased plant water stress, and reduced water security, which in terms of agriculture means an increased dependency on irrigation and reservoir storage. Across much of the US, surface soil moisture is projected to decrease as the climate warms, driven largely by increased evaporation rates due to warmer temperatures. This means that, all else being equal, future droughts in most regions will likely be stronger and potentially last longer. And these trends are likely to be strongest in the Southwest and Southern Great Plains, where precipitation is projected to decrease in most seasons and droughts may become more frequent. And so what does this mean in terms of climate change and soils? We can look to a number of major scientific climate science reports on that connection. The IPCC, or Intergovernmental Panel on Climate Change, and their special report on climate change and land details how climate affects soils and vice versa. Warming of soils and increased litter inputs will accelerate carbon losses through microbial respiration. Dry soil conditions favor or strengthen summer heat wave conditions through reduced evapotranspiration and increased sensible heat. In contrast, wet soil conditions, for example, from irrigation or crop management practices that maintain a cover crop all year round, can actually dampen extreme warm events through increased evapotranspiration and reduced sensible heat. So this last bit highlights the role of soils in buffering the impacts of climate change when coupled with appropriate management. In USDA's Climate Indicators for Agriculture report, soil moisture is an important biophysical indicator of climate change, as it is an integrator of climate impacts on crop production, but it is also affected by changing atmospheric and soil conditions. Soil moisture reflects climate and is a key physical parameter because it integrates the effects of and interacts with a variety of meteorological variables, including precipitation, evapotranspiration, solar radiation, temperature, vapor pressure, and wind. It's also influenced by soil properties such as water capacity, permeability, and organic matter content, as well as by plant properties such as phenology and water use. And we know that excess soil moisture can often be related to increased precipitation that can be detrimental to root growth and crop development. Overall, soil moisture enables evaluation of different soil management practices on plant stress and production in the context of a changing climate. Healthy soils have characteristics that include appropriate levels of nutrients necessary for the production of healthy plants, as well as moderately high levels of organic matter, a soil structure with good aggregation of primary soil particles, and a healthy microbial community. Several of these processes are sensitive to changing climate conditions. Changes to the rate of soil organic matter accumulation will be affected by climate through soil temperature, soil water availability, and the amount of organic matter input from plants. Erosion is also a particular concern. More extreme rainfall events via climate change will contribute to the erosivity of rainfall, snowmelt, and wind. Rainfall's erosive power will increase if increases in annual rainfall amount are accompanied by increases of intensity. Climate change also affects the soil as a buffer and solution to climate change and the climate crisis. While soils are a major source of CO2 and other greenhouse gases, projected warming and precipitation extremes may decrease the overall soil organic carbon pool. Moreover, projected warming may increase emissions of gases from soils. And we also know that climate change and soil health will also affect human health through food security via agricultural production and air quality with increasing dust storms. So what can we do with this information on soil health and climate change? The US government supports a number of organizations that connect climate science to decision makers on the ground, otherwise known as climate services. Enhancing climate resilience requires multiple steps: exploring hazards, assessing vulnerability and risk, investigating options, prioritizing and planning, and taking action. These steps can include the integration of soil health, whether through knowledge exchange, practice, and/or action. Major functions for climate service organizations such as the USDA Climate Hubs, the NOAA RESA program, and the USGS Climate Adaptation Science Centers include convening, translating, collaborating, and partnering. Through these processes, climate services help connect communities and decision makers with decision-relevant, actionable climate information and resources. Beyond climate services, climate change is a priority across the US Department of Agriculture, and I'll highlight some intersections here with soil health and the climate hubs in these two guiding documents prepared in response to the Executive Order 14008 on the climate crisis. The first document here is the 90-day progress report on climate smart agriculture and forestry, which is essentially our mitigation strategy. Climate smart practices include activities that store carbon and improve the resilience of forests and soil, as well, and then can include reduced and no-till, cover crops, and prescribed grazing. The second document refers to the department's adaptation and resilience plan. Related to soil health, I'm focusing on these two department-wide actions. The first discusses building climate resilience using soil and forest health. Enhancing soil and forest health will protect ecosystem functions that support the long-term resilience of working lands and forests and really enable producers to successfully and sustainably enhance productivity. Recent and ongoing USDA NRCS actions include encouraging enrollment in the Conservation Reserve Program, or CRP, funding 85 locally driven public-private partnerships in the Regional Conservation Partnership Program, RCPP, and also investments in the Conservation Innovation Grants, including Soil Health Demonstration Tool. And building on the efforts from the 90-day report, USDA will incentivize and scale up voluntary adoption of soil health enhancing practices. And a combined effort on the part of NRCS, the Farm Service Agency, Forest Service, USDA Research Agency, and the Climate Hubs, along with other USDA agencies, will be essential to implement these actions effectively and address these challenges. The fifth action here is related to USDA Climate Hubs. The Climate Hubs are a unique cross-agency program that really aims to develop and deliver science-based, region-specific information and tools to producers so that they can build climate resilience and reduce their risk. The next portion of this presentation will describe the climate hubs and some soil health specific projects. And I hope that you can use these products, but also find the framework of the climate hubs useful in your own work. So this map displays the 10 hubs and the mission and vision of the network. The hubs essentially help bridge science to practice through the delivery of science-based region-specific information to support climate-informed decision-making, reduce agricultural risk, and build climate resilience. The end goal is that USDA agencies and their partners, forest managers, farmers, and ranchers have useful, usable, and used information and resources about climate change and its impacts when making strategic and operational management decisions. And you can see from the map, there are 10 climate hubs around the country, and I work in the national office, which is located at the USDA headquarters in Washington, D.C. I'm also wearing another hat for a few months as acting director of the Southern Plains Climate Hub. And this shows how we work. The hubs use co-production to facilitate engagement among scientists and decision makers and communities to develop more relevant and useful products. The co-production cycle, as shown here, demonstrates a cyclic process of knowledge exchange, monitoring, and learning that takes place among the hubs and partner groups. The hubs work through USDA and other programs, networks, and initiatives across the country to connect with a wide variety of partners, which includes USDA agencies like NRCS, federal, state, university, tribal, and NGOs, and private sector researchers and advisors in ag and forestry, and farmers, ranchers, and forest managers. And the climate hubs work are covered in these three main work streams shown here on the right. The first is data and data synthesis, which include regional assessments of risk and vulnerability to production sectors and rural economies. And this includes writing portions of the National Climate Assessment. And between 2014 and 2019, the hubs led or participated in over 410 peer-reviewed publications, many of which also address soil health and its connection to climate change. The hubs also deliver science-based ag, forestry, and land management tools and technologies here in our second work stream. And this is for responding to the impacts of a changing climate, including drought, extreme weather events, and changing growing seasons. The hubs help improve access and create more usable regional data and climate change projections and forecasts in support of risk management and climate adaptation planning. Finally, the hubs provide outreach and education to farmers, ranchers, and forest landowners on science-based risk management. In the last 5 years, the climate hubs and their partners have hosted over 500 in-person events, reaching over 16,000 stakeholders. And these next few slides will cover a few products from each of these work streams that address soil health. And again, I hope you find these products useful in your own work. This first is called the Ag Risk Viewer. And so in partnership with the Agricultural Research Service and Risk Management Agency, the Southwest Climate Hub developed the Ag Risk Viewer, which brings to life 30 years of crop insurance data. The Ag Risk Viewer allows users to explore, visualize, and analyze publicly available crop insurance data at multiple spatial and temporal scales by commodity, like wheat or corn, and by cause of loss, like drought or hail. The Ag Risk Viewer can be used to highlight hotspots of consistent weather and climate-related losses on agricultural production and pinpoint trends of drought-related losses on specific crops, for example. The platform could also be used to highlight hotspots or cold spots of climate-smart strategies and soil health practices. Moreover, the Ag Risk Viewer could be used to better target soil health practices in areas with higher insurance payouts of drought, excess moisture, and/or flooding. We could also use these crop insurance data to better understand agricultural risk management alongside other environmental management variables such as irrigation water use and groundwater data. Over the Ogallala Aquifer, we found that different soil management practices arise due to climate change impacts, among other factors. For example, in the northern Ogallala, there was more irrigation water use due to abundant water supplies as demonstrated by lower drought payments and higher payments due to hail. However, in the southern Ogallala, adaptive management strategies may be more prevalent due to higher losses due to drought, less irrigation water available, and a declining water table. Another resource that might be of interest and useful is the Dust Mitigation Handbook developed in partnership with NRCS, the USDA Southern Plains and Southwest Climate Hubs. Increased dust emissions from cropland and rangeland can be problematic in many areas, particularly where dry conditions and high wind velocities exist. Moreover, there are important ecological and hazard implications. Soil loss and redistribution from aeolian activity affects soil health, nutrient cycling, and land potentials. Dust emissions also impact air quality and human health. Producers and specialists need a resource with in-depth solutions to specific dust and wind erosion problems. for a changing future where uncertain climate and water supply conditions may prompt farmers to fallow increasing acreage of once actively planted cropland, this handbook comes as a timely resource. The handbook also offers a one-stop shop describing airborne particulates, wind erosion, conservation planning, wind erosion abatement, and USDA programs to address wind erosion. The Northeast Climate Hub has been at the leading edge of better understanding the economic dimensions of soil health, specifically looking at the impacts of both no-till and cover cropping systems. This includes examining carbon sequestration benefits of different soil health practices by bringing together economists and soil health scientists, which is especially important for private landowners as soil health benefits often need to outweigh the cost to adopt a certain soil health practice. This type of long-term economic outcome data can help determine potential incentives for farmers. Understanding the motivations for adopting proper soil health management strategies could increase adoption. Different cost share payment programs may affect what soil health practices are adopted and how these programs may interact with other government-supported programs. Adequately determining the best incentivization for farmers and soil health practices may help reduce climate change impacts while also creating a positive economic impact for the agricultural industry. The Southern Plains Climate Hub, in partnership with NRCS, the Soil Carbon Coalition, Redlands Community College, and Dixon Water Foundation, produced this Soil Health and Watershed Function Teacher's Manual, so more on the education and outreach side. The workbook focuses on soil biology's role in the water cycle, providing a foundation for participants and students to build a basic understanding of soil health through respectful discussions and shared listening, increased sense of curiosity and hopefulness, and increased sense of agency in managing processes in agricultural and other landscapes, knowing the kinds of questions to ask in order to discover what is needed and how to tell if it's working. The investigations and activities provide students ample opportunities to absorb three large concepts. One, that soil structure has a large influence on the water cycle, which makes life on land possible for humans and other species. Second, plants and microbes create soil structure through the work they do, and it's easily overlooked. And third, human decisions about land management dramatically affect other species' capacity to do this work. And if we understand the work of other species, we can participate in the processes and have a positive impact. Another outreach example I'd like to highlight is field tours, virtual field tours. We know that field tours are a powerful teacher because they are an ideal way to see how farm and forestry practices work in the real world. The Northeast Climate Hub partnered with the University of Delaware Cooperative Extension and other land-grant universities in the region to showcase adaptation and mitigation practices at existing farm and forest sites. The innovative 360 photography and videos offer an interactive experience, and users can consider the experiences of others who are dealing with and adapting to increasing rainfall intensity and other weather and climate risks in the Northeast, and meet the people who are addressing these issues. And these two pictures show a specific example at the University of Delaware's Warrington Irrigation Research Farm in Delaware, where researchers are improving irrigation to boost crop yields and manage soil and water resources. Water is one of the most critical crop needs. By improving water management, farmers can be sure that their crops receive adequate water throughout the growing season. A more efficient irrigation system can save money, energy, and reduce carbon dioxide emissions. In the Mid-Atlantic region, high heat and droughts are likely to become more common as the climate changes. Irrigation is widely used to protect crop yields during these extreme events. And so more efficient use of water will help growers maintain or increase their crop yields under a changing climate and also better protect the environment. And this is just one of many examples of these amazing virtual tours through the Northeast Climate Hub. And finally, the climate hubs have built and support peer-to-peer learning networks to empower producers around climate change and impacts. And these examples may offer opportunities for further integrating soil health and those discussions in these peer-to-peer groups. The first example I'll highlight here is the Drought Learning Network. That's a concept developed out of our Southwest Climate Hub and has been implemented in the Southwest and starting up in the Caribbean. The Drought Learning Network is a consortium of climate service providers and resource managers and strives to share critical drought-related knowledge to build future resilience. We know that soil health is affected by drought, and this Drought Learning Network may provide insight on how to share best practices and knowledge around soil health. The second example here is the Climate Adaptation Fellowship Program, and that was also developed out of our Northeast Climate Hub. And that's designed to help farmers, foresters, and service providers in the Northeast improve their knowledge about climate change impacts and their ability to make good planning decisions related to climate change adaptation. The Fellows Program uses a peer-to-peer learning model for farmers and advisors. Its framework integrates climate science with land managers' knowledge, and fellows work in farmer-advisor pairs to develop personalized farm adaptation plans for the year-long program. In January 2021, 40 vegetable and berry growers and advisors started the year-long peer learning program. Successful applicants to the fellowship highlighted their interest in learning more about ways their operations can continue to support climate mitigation adaptation efforts. And so that was a whirlwind of climate science and climate services, but also I hope I provided you some products I hope you can take with you in your own work as you work to support soil health efforts, but also in relation to climate change and its impacts on soil health. And so just want to thank Margaret and Steve and everyone for the opportunity to present on the climate hubs and also some climate science efforts. Thank you.
Thank you so much, Julian. That was precisely what we hoped you'd be able to provide, and you did it not only extremely well, but so in such a timely way. I think you and Dr. David Montgomery win the prize for fast, precise speech. So we're going to take a few questions here. And so I'm going to once again ask, if you don't mind, Chris Lint, if you who have been monitoring questions in the Q&A box, if you have some, that this would be a perfect time to jump in, sharing those. And if it would be helpful, I have a couple that I've been interested in, just thinking about what you do. So I'm going to give a second for Chris to let me know if you have some, or otherwise I'll jump in. Not hearing, and you're going to continue to be welcome to jump in when you're able to, Chris, but I'm going to go ahead and get started. I'm curious, as you, as the climate hubs engage in your work, who do you see as your principal stakeholders? Who comes to you? Who comes to you asking for help? Do you have some weird motley crew of individual farmers and universities and NGOs? Do you have a kind of, is it an obvious theme? That's question number one for me. Who comes to you?
Great question. And I had another slide for that with showing all of our stakeholders. It's all of the above. It's first I mentioned the USDA agency, so NRCS, FSA, RMA, ARS, Forest Service, the list goes on. They come to the climate hubs for help on climate change information, climate science, or just ask, how can we best reach producers on the ground, because the hubs have that presence in many local areas, and they are that trusted organization to kind of transfer or share climate knowledge. And so, yes, the USDA agencies themselves, I'd say across the federal government, the hubs also offer their expertise on climate change and agriculture to other USDA, US agencies, including NOAA, FEMA, and the list goes on and on. And then besides the federal agencies, the hubs, they're the trusted community partner for many producers on the ground, farmers, ranchers, forest landowners. So to your point, Margaret, also, we are providing information to them, and they are asking for more information, such as on soil carbon sequestration, right, which is where the Northeast Hub is doing the synthesis on the economic dimensions of soil health. I think also land grant universities, very recently, the National Institutes of Food and Agriculture, NIFA, provided about $9 million for 6 new funded climate hub and extension partnerships. And so again, to that important role of working through extension and supporting them, they are the boots on the ground, because the hubs have only so few staff, right? And so we rely on extension to be the voice for the hubs, and we work with them to get those resources out there. So it's everyone, as many people know, especially in the climate world, the demand for our services vastly exceeds our supply, and how we can really do the best job. We're doing the best job we can, rising to the occasion to address all those. But, we only have so few staff to, help everyone that we can, but we're doing our best.
I'm sure that you are. Thank you. So I think I saw that Chris, you are now co-host. Do you have some questions that have come up for clarification? Just brief questions here. This is just going to be a 5-minute Q&A. Anything else?
Yeah, The audience has been a little shy in questions, but we do have at least one specific question. When Dr. Reyes was speaking about his temperature increase projections at the beginning of his talk, a question came in about, are those projections taking the coming solar minimum into account?
That's a great question. And so I took these results from the 4th National Climate Assessment. And so that was produced back in 2018. And so, oh, can you hear me?
We can hear you now.
Sorry, I clicked something. So no, it does not take that into account, but I am not aware of how the projections from the model specifically take into account solar projections. But what I can say is that the National Climate Assessment is our go-to in terms of climate change impacts on agriculture, but also what is happening in terms of temperature and precipitation. You know, the National Climate Assessment is congressionally mandated coming out of the Global Change Research Act of 1990, and we're currently in the 5th National Climate Assessment, which is being produced. And so, you know, the National Climate Assessment is based off of the best available peer-reviewed literature. We synthesize that information. It's also based on the best available models on climate science. And so I can't answer that specific question, but I hope you look up the 5th National Climate Assessment. You are able to provide that input into the process, since it is a publicly available process for you to be able to note your concerns if that particular process is not included in the temperature modeling specifically.
Thank you very much. I really have, I'm excited that you're not only here for this panel and this discussion, but also for the panel that follows. And for those who joined late, I'm just going to remind you that we have a kind of sibling panel that's sequenced after this one for reasons that are going to become obvious, which is entitled Soil Health for Watersheds. How can federal agencies help? And so it's great that we're going to have Dr. Reyes for that as well. But for the moment, we will continue. And again, just since I know people have to come in a bit late, especially at the lunch hour, I will reiterate what I explained earlier, that the 2 papers that we're about to discuss were emerged from a collaborative discussion, iterative process. And the idea is we grab hold of a topic and really discuss it ourselves, have a paper out there that kind of provokes some conversation, and then ask at the end, what else should we be asking? What are the other topics? What remains to be discussed? What remains to be researched? And how do we proceed from here? And so the group that has been growing in number, and anyone on this call is very welcome to join us. And I will put my contact information in the chat box in a bit. We started last summer with a survey. What are the topics that we should start with was the question. And the choice was how do different conservation and soil health building practices reduce the quantity and quality of water leaving farm fields from storms of different severity and timing. And the first, we kind of broke ourselves into 2 groups. One is we called ourselves the biophysical group, and we have the other one that we call the costs and valuation group. And we're going to hear from the biophysical one first. And I'm thrilled that we were able to persuade Dr. Dianna Bagnall, who is part of our group with the Soil Health Institute, invited her and asked her to please be the person who was able to take all that she was hearing and create an orderly process that was a collaborative one, but that ended up with a paper that we could all discuss, which she did with aplomb. She is an applied soil physical science physicist, applied soil physicist specializing in soil physical health and socioeconomic dynamics of soil management. And her research includes developing functions that show the effect of soil carbon on plant available water, on-farm soil health assessments, qualitative analysis of farmer interviews, development of novel soil structure scanning methodology, and both measurement and modeling of preferential water flow in shrink swell soils. I'll say in addition to that, she is a dynamite collaborator. So Dianna Bagnall, we look forward to having the camera turned to you, and you bring up your presentation for your paper.
Thank you very much, Margaret. Can you hear me all right?
We can hear you and see you.
Fantastic. I am going to see if I can screen share here. Well, it seems that that's been disabled at the moment, so maybe we can work on that on the technical side. But I'll just say that I think this was a fantastic setup, and I really appreciate Julian's introduction. I should have him speak every time before I give a talk, and I'm sure that I would people would pay much more attention. So that's fantastic. Does not look like we have a participant screen sharing though.
Chris, you were listed as having been, it shifted to you as the co-host. I wonder if you are in a position to make sure that Dianna gets that capacity. Jason, I think if you,
I will give it a shot.
okay, thank you. It may be that Jason needs to do this.
If we didn't have anything go wrong on Zoom, we would just all be suspicious. So it's fine that it's me. We'll get it all sorted. I'm sure it'll go smoothly after that.
There you go. Looks like it's going to happen. No, but it's Chris Lentz screen share. We are viewing Chris Lent's screen, and we really want to have Dianna able to be a co-host so that she can share.
Dianna, can you try again?
Yes, let me give it another go. No, it does say host has disabled participants screen sharing.
So I will note that NCAT took the precaution of asking all speakers to send along their presentation. So NCAT, you actually have Dr. Bagnall's presentation, and maybe it would make sense for you just to simply move it. There you go. There you are. So it just means you're going to have to say, click, 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 as you speak, Dianna.
Sure, I'll be very annoying because I love animations, and so I'll warn you in advance that this may be brutal, but I'll give a go ahead. So thank you for getting that sorted out. My name is Dianna Bagnall, and I work for the Soil Health Institute. Soil scientists are not known for short, catchy titles, so biophysical dynamics of soil health and hydrological ecosystem services is our discussion today. So we can go ahead and advance. It does look like we're viewing in notes mode. I'm not sure if we can switch to the full screen. But you know, Margaret has given such a great overview of the process that I'll just go ahead and talk briefly about the contents of the paper. I'm not sure if we can go ahead and advance to the next slide, but it would be also great if we could see it in presentation mode instead of in, and you may be able to do display settings up at the top and be able to switch display on the left-hand side. There we go. And swap. Yep, that one would be great. The top one right there, swap presenter. Perfect. Okay. And if you can go ahead and click through a couple of times and we'll get the rest of the contents up there. So today we're going to talk a little bit about why we're talking about soil health when we're really interested in flooding is our main interest. And so we'll do that. We'll talk about the data which we looked at in our paper. There were two main sources. One, we wanted to look at the observations of farmers and ranchers, the soil health practitioners on the ground. We'll also look at peer-reviewed literature to corroborate those results, and we'll look at gaps and next steps. If you'd advance the slide, next. And then I'm going to give you a bonus, which is an example from my work that I think ties in really well to this content, and especially given Julian's great setup. So here on this slide, I just wanted to take a moment and really talk about the fact that there's a lot of biophysical processes going on here. We're talking about soil, and when rain falls on soil, how it gets partitioned either into runoff that can cause flooding and damages. And if you advance that, click a couple of times and we'll get some text up on the slide here. If you'd advance the slide. That'd be great. So I'll go ahead and say that this has been covered well in terms of the need to assess flooding. But I think that an important aspect as we stare at this diagram looking at infiltration and percolation and base flow is that in order to be predictive about how our management practices can influence our offsite challenges like flooding, we really have to understand mathematically these biophysical dynamics of the differences in what soil management can do for these different processes. So if you please go ahead and click to the next slide. We will get ourselves started with our soil health management practices. So I love this picture. It's a really clear example. On the left-hand side, we have no-till and residue. And what we're doing here is allowing our soil health to improve. If you click a couple of times and bring the text up here, we're seeing that soil health management practices manifest principles like keeping living roots in the soil, keeping our soil armored with residue, and reducing disturbance. And the effects are that left-hand side where we've had the water infiltrate, as opposed to the right-hand side where we have continued soil disturbance and low levels of biodiversity, no protection on the soil surface. And the outcome of that is that we have water running off the field and damaging the offsite areas. So if you click one more time, what we've got here is the goal of our work, which was we wanted to look at those offsite questions, but we needed to understand these biophysical relationships involved in soil and water on our agricultural landscapes and understand what we do know, but also outline what we don't know in terms of the effects of water quantity and quality. Please advance the slide. And so we want to assess soil health, and we're really talking about looking at indicators that are conceptually linked to hydrology. So you can go ahead and if you'd advance infiltration rate, available water holding capacity, bulk density, aggregate stability, soil organic carbon, these are all indicators of soil health, but some are more direct than others. So infiltration rate, really we can find good relationships between infiltration rate and maybe offsite consequences. Whereas other things, for example, soil organic carbon, very, very important, but it's not quite as direct of a measurement when we're interested in looking at those biophysical dynamics connected to flooding. So if you advance once again, the things to keep in mind are that when we want to measure these indicators of soil health so that we can understand how our soil health management practices will influence the on-farm and then the off-farm ecosystem services, there's a lot of noise in soil inherent properties and climate and seasonal changes. And so we had all these factors. We had lots of great discussions about how we assess soil health and how we should measure it. And what we came to was wanting to understand what real people on the landscape are actually seeing in terms of soil health management. So if you advance the slide, that'll take us to our next bit of the puzzle here, where we see that practitioners are able to observe changes of soil health on their farms. And I mentioned before, we have to keep this chain in our minds, that we have a management practice that changes, it influences indicators of soil health, that influences soil health properties on the field, and then we can draw inferences about flooding outcomes. Please advance. And so there are some drawbacks to looking at practitioner observations, and we wanted to be clear about those. Frequently, when a producer, a rancher, or farmer makes changes, they don't look at repeatability. They're looking for what works on their field. And they often don't have a control scenario because they're more interested in just finding something that works. So those are disadvantages. But on the other hand, if you'd advance the slide, we have a lot of advantages of these observations too. A huge advantage is that this is real world. This is something that actually worked, that integrates the dynamics of the whole farm. That's typically not something that we see when we look at research trials. And as well, they seek out synergies because they're really not so interested in isolating for, let's say, the effect of cover crops as they are on making sure they have the right synergy between, say, cover crops and reduced tillage to really make things work. So when we had these practitioner observations, we, as a team, looked through what we could find and the different stories, and we drew out themes that were recurring and we thought indicated positive trends. And so if you'd advance the slide, what I've done on this next slide is just aggregate some information about the themes that emerged. And there were three primary themes. One, and I've got these listed by column, were that they were observing indicator changes, specifically looking at organic matter and infiltration. As well, profitability was something that our producers, our farmers and ranchers always seemed to be mentioning. And then they also were highlighting those synergies between the management practices and the co-benefits of adopting soil health. And so just to kind of give you a taste, I'm not going to give you all the details from the paper, but just a taste of the fact that broad geographies, you see a lot of different areas listed here, as well as broad commodities were represented in these producer observations. Advance the slide, please. And so here I've thrown at you some numbers, some details in those same three categories, those themes that we kept hearing again and again. Producers mentioned how much soil organic carbon, that indicator of soil health management change, was in their field, 0.5% per year. There were lower values, there were higher values, but that was a recurring theme. During my doctoral work, I argued with some economists that producers really understand the value of knowing how quickly water infiltrates into their fields. So this was very affirming for me as a soil scientist to see many producers talk about, you know, the first half an inch of water is infiltrating in this trial in 4 seconds, and I'm able to see infiltration rates as high as 15 inches an hour. But as well, these individuals, these practitioners of soil health, always tied that to their profitability. This was not something we set out to find. We were really focused on biophysical dynamics, and yet it kept coming up so frequently that we didn't want to ignore it. And so some examples here of reducing fertilizer costs, of winning yield contests after having been able to switch to no-till and cover crops. The last two pieces in these columns on profitability, one is a study from the Soil Health Institute, and then the last row there in the middle column is a USDA study showing 176% return from soil health investments. And lastly, that theme of synergies and co-benefits, listing ways that these kind of adaptive management strategies were benefiting them in terms of independence, in the case of a market garden that was looking at earlier planting, independence from tractors, extending their harvest and getting to break into new markets. In the case of some cattle grazing operations, one obtained an Audubon bird-friendly certification, which was helpful for them in marketing. And another was able to show that their pasture-raised beef was actually storing more carbon than it emitted. So I've thrown a lot at you there in terms of producer observations. In my next slide, I want to talk a little bit about our foray into peer-reviewed literature. By no means is this a meta-analysis of other meta-analyses, but we wanted to make sure and kind of true up what we were finding in terms of infiltration, especially with the peer-reviewed literature. So two kind of emerging themes under the peer-reviewed literature that got there at the top in white. One was when we found literature that was directly connecting changes in practices to changes in infiltration. And so here are some examples showing that things like introducing cover crops, switching to perennials, or more intentionally managed grazing was increasing infiltration rates. Then on the right-hand side in that column, we have kind of a step back in that causal chain. If you remember it, we had changes in practices that change indicators, which change the soil health and then the flooding outcomes. So in this meta-analysis, they were showing the increased carbon when they were going to a conservation tillage. So these are the two kind of bodies of evidence that we found. But on my next slide, I want to talk a little bit more, both on summarizing those points in the first two bullets. First, practitioners of soil health are observing benefits, and they're doing it both in terms of indicators of soil health and in terms of their increased profitability. That is how they measure things. Our literature generally supports that soil health management practices improve soil health indicators. But we also wanted to look at, what we needed. We need to be able to inform policy and stakeholder choices. We need to be able to select the right management practices for off-site hydrology goals. And that is hindered because currently our models don't really capture dynamic soil properties. As well, it's really difficult to scale our knowledge from a small scale, say a field, to a watershed. And it's also really critical that we have that right data. So these next steps that we recommended, where we need to find ways to improve hydrology models in a way that better incorporates those dynamic soil health properties. And when possible, we need to have large scale studies, watershed studies that both look at paired watersheds in some cases, or a kind of pre-post where we change the management and we look at what happened afterwards. So those are the paper recommendations, but I wanted on my next slide, I'm going to cheat here a little bit and just give a really concrete example from my work of what it looks like when we think about soil health and we build it into our mathematical models. So in this diagram on the y-axis there on the left, I have plant available water holding content. And this was something that Julian mentioned as being important, not just for provision of water to crops, but as well, it has a lot of consequences for heat balance and drought and other things. And then we know that different soils can store different amounts of water. So clay content is representing that change in soils on the x-axis. And so the data, the little line that you see there, the gold line, is a very well-known function that takes sand and clay and soil organic carbon and predicts plant available water. It was developed in 2006 from over 2,000 measurements that the NRCS put forward. Really useful equation. And yet when we took that equation and we plugged in four different values of soil organic carbon, 1, 2, 3, and 4%, there was so little change that those four lines are overlapping in this graph. You cannot see the magnitude of the effect of changing soil organic carbon, which is widely known to be an outcome of changing soil health management practices, in the available water that's predicted in this equation that is embedded in probably every model out there that deals with plant available water. And so the reason is because the data were collected across landscapes to ask the scientific question, how do soils change across landscapes? If you advance the slide, you see a new set of lines. Those new green lines were built with the same structure of an equation, exactly the same, except that they were created with the new data from 2019, the Soil Health Institute collected across 124 long-term research sites in North America. And so what's happening is that we selected sites which themselves showed the effect of management on soil organic carbon and that effect of soil organic carbon on plant available water. And the magnitude is clear. When we go from 1 to 2 to 3 to 4% soil organic carbon, we now see meaningful changes in plant available water. So I wanted to take this as an example of the way that we have to walk back our understanding of these dynamic processes, think about the effect of soil health management, collect data in an appropriate experimental design, and capture that information in mathematical relationships that can inform not only field level attributes like plant available water, but ultimately that can underpin new understandings of hydrological ecosystem services based on soil health management. So with that, I'm going to go ahead and go to I believe it's my last slide is next. So if you advance, yeah, that's all for me there. And I will open up Margaret in case we have time for questions.
We do, and thank you so much, Dianna. That was, of course, terrific. And so I'm once again going to say we're just going to take a very short period of time here, just 5 minutes for a quick Q&A, so that if there's any clarification that people need to understand what you've just said, they have a chance to do that. We'll go into a broader discussions later after we've had a chance to hear from Juli Obudzinski. So Chris, I'll once again invite you to step in, and if you identified any questions in the Q&A. I'm not able to see the Q&A, so that's I depend upon you.
Yep, we we do have one question that came in that may relate to what Dianna was talking about in the end, at the end of her talk there. It has to do with the mineral content of water and how that affects its availability for plant uptake. Has there been any research done on that you know of, or can you address that in any way? And have you, the question itself asks if anything has looked at the impact of magnets to reduce minerals in irrigation water and how that affects water availability to plants.
Yeah, so I would say that that particular question in terms of ways to mitigate minerals in irrigation water is not something I've studied. I do know that certainly the source of irrigation water can have a lot to do with nutrient uptake by plants, but that's a little bit beyond kind of getting into the nutritional side and a little bit beyond the immediate concerns here.
Yeah, great. I have one quick question for you, and that is, if you were, I mean, you're trying to help us develop the answers to the questions. How do we take what we know from the soil science research and bring it into the actual geography of watersheds and the hydrogeology that is what is going to be influenced by climate change? And if you were to design the perfect project or set of projects, what would they be? Can you give a quick description? You just shared a little bit at the very end. And if you were to kind of encapsulate your idea of the critical principles that we need to pursue.
Yeah, I think that in order to do it well, it really has to be thought on the front end. And that the first piece would be to get the folks in the same room to really map out conceptually all the ways we believe management practices could affect these dynamic properties. And only at that point can we then take a catalog of all the models that are out there and kind of compare the two and say, you know, what are we missing? And I find that that is just unspeakably common, that we go into solving the problem without having asked, well, what might we think can be the connections? Simple example from my own work. We had an opportunity to alter the soil structure in a hydrology model. We saw results that made a lot of sense, but the next thing we know, we were getting odd runoff predictions. And when we went back to take a look at those, we realized there was no effect of no tillage and cover crops on the surface roughness and therefore the runoff. And so you're back to the drawing board. So a collaborative team with a very strong vision to understand conceptually what the pathways of these dynamic properties are, then cataloging your models and identifying the right experimental design needed going forward is I think what I do.
Thank you very much. I think we're going to go on ahead. I'm conscious of time, and I know we want to have a broader discussion at the end. So once again, thank you very much. And we are now going to have our last discussion paper. This is going to be presented by Juli Obudzinski. And Juli led the writing of the discussion that came out of the group dealing with costs and valuation. Juli is, I'm going to say her last name again. I'm sure if you're Juli Obudzinski, you wish people would say it routinely and pronounce it correctly. Obudzinski. Juli is a very seasoned policy consultant and a policy professional. She has worked for a number of years at the federal level on federal policies. She was, until 2021, the Deputy Policy Director for the National Sustainable Agriculture Coalition based in Washington, D.C., where she coordinated the coalition's federal policy work. She's worked extensively on sustainable agriculture policy priorities in the 2014 and 2018 farm bills, coordinating direct advocacy strategies on Capitol Hill. She previously worked at the USDA and at the Leopold Center for Sustainable Agriculture at Iowa State University. She's serves and has served on a number of USDA national committees. she is going to bring together a wide variety of issues that this group has tried to grapple with to understand again what is the relationship between soil health and what the kind of water that we see tearing down through our landscapes. How can we get our handle on the cost savings? So Julie, thank you so much for joining us.
Great, thank you. I'm excited to be here. So as Margaret talked about earlier in the introduction, the broad focus of this project was to measure the societal benefits of soil health. Dianna did a really good and fascinating presentation, which is focusing mostly on the ability of healthy soils to reduce flood risk. So how our paper and our research works into this, we really looked at the potential economic value and the cost savings of soil health that may reduce risk of flooding or pollution downstream. So we're really focused on the non-farm costs. Next slide. And once we get the next slide, fantastic. So these were the two research questions that we were looking at. Similarly, we had a similar chart of really narrowing our focus. Like I said, there's been a lot of focus on-farm benefits of soil health. We were really interested in some of these non-farm costs and benefits. So the first question really gets at looking at what some of the downstream costs are that are associated with ag runoff. We looked at many different stakeholders, individuals, governments at the local scale, at the state level, at the federal scale. And then the second question is really looking at then what would be the value to all of those stakeholders of potentially reducing flooding and water contamination. Next slide. So why did we focus on kind of these two primary questions? As we've talked about, there's been a lot of interest in soil health, which is a really good thing. To date, most of the focus of the discussions was looking at the cost benefit to farmers. I think that's for obvious reasons. There's been very little conversation about talking about soil health and the benefit off farm or to the broader public. I think especially with some of the recent disasters that we've been seeing and all of the interest in climate change, there has been more of an interest in trying to figure out what are some of the downstream impacts of what happens on farm. So our research, we really were looking at how do we think about incentives that might be more based on a cost prevention, taxpayer protection paradigm, rather than just looking at the cost benefit to the individual farmer. I think they're both needed, but really looking at soil health from a different vantage point. Next slide. So our framework, similar to Dianna's, we really were looking at two different things when we were looking at the improvements in soil health and the possibility of those improvements to increase water holding capacity and therefore reducing runoff. So when we talk about water, we were looking at two things: water quantity and water quality. Water quantity, it's pretty self-explanatory, how much water is leaving farms and how much water might therefore potentially increase the risk of flooding off farms. And then the second issue is really looking at the quality of that water. So what is being carried with the water that leaves farms? So we're thinking about fertilizer, we're thinking about nutrients, pesticides, et cetera. And that may reduce off-farm and potential contamination downstream. It was really impossible when we were having a lot of these discussions to talk about flooding without also talking about water contamination and impaired watersheds. So we did look at both of them in our analysis. Next slide. All right. So obviously, when we think about some of these costs, and as was set up in the research questions that we asked, the costs and the impacts that we're seeing off farm occur at very different scales. So these are just some of the examples of some of the costs that we were looking at. So individual homeowners, what are the costs and the impact to businesses? How does that differ on small businesses versus large businesses? Local municipalities, we spent a lot of time looking at rural towns, rural municipalities. What's the cost to the state and to state budgets? And obviously, what is the cost to the federal taxpayer? This makes quantifying the total costs very, very difficult and hard to measure, which on the next slide, I'm going to walk through an example that we put to try to illustrate how complex this issue is. If you can advance to the next slide. Okay, so this slide is really, I'm sure it makes a ton of sense. I'm just gonna explain it anyways. We're really trying to illustrate the complexity of these costs. So it outlines the different types of costs and the different scales of impact. And this is from flooding and contamination. So basically, what impact does flooding and water contamination have, and then who pays for it? So around the corner, those images in the corners, those illustrate the different types of impact, and they're examples of different types of impact of both flooding and contamination. The images in the middle represent the different types of public funding sources that may partially compensate for some of those impacts. So we know, for example, private homeowners bear most of the costs of repairing homes, replacing personal property. Some assistance may be offered, and we'll talk a little bit about the complexity of this. Some assistance might be offered through FEMA's National Flood Insurance Program. Not all of it, and only in certain cases, but that's funded by federal taxpayers. However, there are other costs, such as repair of roads, repair of schools, that may be more borne on state and local municipalities or state and local governments to help with some of the recovery costs. And then there might be others that are impossible to measure or have yet to be measured. So I'll talk about this concept of community collapse and loss of rural vitality. Obviously, impacts on wildlife is another one that we'll talk about specifically with water contamination, but really, really hard to measure those costs. So this wide range of costs that we see and funding streams in terms of who actually pays for it makes the assessment of that cost benefit analysis very, very difficult to assess. What we did find in our research, it's easier to quantify costs for a specific event and at a specific scale. So for example, what is the total damage to the city of Cedar Rapids from the 2008 flood? We have a really good case study that went into some of those numbers, a specific event, a specific period, and a specific location. It's a lot harder to quantify, especially the cumulative costs that are across multiple scales and multiple different timeframes. So for example, what are the costs of chronic flooding in rural communities to the federal taxpayer? So that would be a much more difficult question to answer. Next slide. So wrap our heads around, how do we start to answer this question of what are some of the costs? We organize both indirect and direct costs into these 4 categories. I'll note that some of these costs are more related to impacts of flooding. Some of them are more related to water contaminations, and some are both. So I will, on the next slide, I'll just start walking through in just a little bit more detail. So the first bucket is this infrastructure damage or infrastructure costs. Not all of this is damage. Some of them are just costs. This is probably the most visible, especially when we think about flooding impacts. We see all of the images of all of the damage. I just showed you some of the damage in terms of damage to buildings, damage to homes, damage to business. Damage to public infrastructure is probably the single most costly for rural communities, for states and other local governments, especially as a result of both extreme and chronic flooding. So what's included in public infrastructure? Some of the things on this list: transportation, for example, roads, bridges, railroads, all of that falls within the public infrastructure category. Schools, hospitals, government buildings, utilities is another big one that we hadn't looked at previously. Flood prevention, anything that falls into the flood prevention category can be very, very expensive. Construction, maintenance, repairs to dams, all of that, all of this mostly falls on the local government and the public infrastructure section. Flood recovery is also very, very costly. We had some really good examples of the cost of dredging waterways, especially if they're used for navigation and transportation. So this would be mostly from sediment deposits, meeting emergency needs of affected communities. Another one that I wanted to highlight here, the cost of treating both waste and drinking water was another cost that came up in a lot of our case studies, a lot of our conversations. And this is especially costly for small towns and municipalities. We had a really good case study that looked at how costly it can be, especially to try to remove pesticides and nitrates from rural drinking water supplies or drinking water supplies for towns in rural areas, and that many small towns simply can't afford it. And so on the next slide, if you can transition to some of the public health and safety costs, we really do look at what is the cost then, if you can advance to the next slide. So what is the cost in terms of public health and safety if a small town and community isn't able to treat their water and they have to find an alternative drinking water source, even if it's temporarily? So that's obviously a cost. Evacuation costs also fell into the public health and safety. We know that there are impacts on businesses. We looked at this. We didn't find a ton of data. I would love to do more research on the brewing industry and other industries that require clean water. So what are some of the potential costs or the actual costs, especially as there are, more brewers and more businesses in smaller towns or rural communities? What might then be the costs on that sector? Obviously, loss of life, health impacts. There has been some data and some research on human health impacts of nitrates, for example. Ecological costs, we didn't spend a ton of time looking at this. Mostly, it's really hard to quantify. I know there is some research out there trying to put a price tag on, loss of biodiversity, wildlife impacts, but more research is definitely needed on that. Next slide. This is the last category of costs that we looked at, and this is really looking at some of the other factors that are, aside from infrastructure, aside from public health and ecological costs, what are some of the other both direct and indirect costs? So supply chain and business disruptions came up a lot in our conversations, especially in our case studies. We know that one of the most immediate impacts, especially from flooding, and it can be both extreme or kind of these chronic, more smaller mid-scale floods, is a loss of sales from small businesses. However, ripple effects can certainly extend beyond the supply chain, especially if transportation is disrupted or there's other impacts along the supply chain. The second two bullets, the tourism and recreation revenue and housing values. This was something that we hadn't thought about coming into this conversation about potential costs. We have a really good case study that's looking at some of the impacts of impaired water. I was looking at the Red Cedar watershed in Wisconsin, and they actually tried to quantify at the watershed level how much money they're losing in potential tourism, potential recreation, because they have a severely impaired lake that's in that watershed. They tried to actually quantify that, and quantifying also the housing values and property values. How much are they losing in tax revenue because of the impairment of their water? So something that was definitely fascinating to look at. The other thing I wanted to highlight here is this risk of community collapse that I mentioned before, which is really, really hard to actually quantify. If you lose an entire community, an entire town, which certainly does happen after both extreme events, but also after some of these recurring chronic flooding that came up time and time again in our discussions. Many residents, many businesses choose not to return. So that certainly can have a cost as well. Next slide. So all that being said, those were the costs that we looked at. That's kind of how we tried to organize them. We did compile whatever data we could find across all of those categories. It was a lot easier to find national data for some of these categories, or it was easier to find local data, and that was primarily through the case studies. So if you review the report, you'll see there's some national data, and then there's a lot of case studies. It's really that in between, especially the state level, the regional level, it was a lot harder. There was a lot more variability. We know obviously public losses, especially due to flooding, are extensive. They're expected to increase with climate change. About 12 to 17 billion nationally is the current estimate. Loss of property is one of the costs that it was easier to find some estimates. We know it's a significant cost, and loss of property is both residential and to businesses. And the important thing that I did want to highlight here is that most of the costs are not compensated. So even though we have, the flood insurance program, we do have some resources out there, a lot of the costs are not compensated. So it leaves homeowners and small businesses on the hook for a lot of these costs. Let's go to the next slide. So obviously, trying to quantify all these difficult costs, or all of these costs proved to be pretty difficult, especially because we were trying to do it at various scales. But one thing that I did want to point out is that even though through our discussions and our research, we didn't come up with the number or the cost benefit analysis that we really wanted to at the beginning, one really, really important takeaway from our discussions is we know these costs are not zero. So we know that these costs exist. As I just outlined, there are probably even, we tried to be really comprehensive with all of the possible costs. There could be more that we didn't look at, but we know that they're not zero. We know that they exist. And so this actually points to future areas of research and analysis, is trying to be a little bit more granular, again, across all those scales. So it could be starting at the case study level. It could be expanding to the watershed level, to the state level, and then to the national level. But we know the costs aren't zero, and we know we have more work to do. So the next slide is talking about some of the themes and findings. I've gone over a lot of this in the presentation so far, so I won't spend a ton of time in it. So obviously flooding, and the first bullet should actually be both flooding and contamination of water, and especially that chronic runoff. It does threaten rural viability and wealth generation. So we found there were significant impacts on both local expenditures. So this is the actual money going out the door, especially for rural communities, small towns, to address flooding or to prevent flooding, or to combat some of the issues related to contamination, such as the example I raised with the water purification and nitrate removal systems. So we know there's significant impacts on expenditures, and there's also impacts because of the loss of potential revenue. So when I talked about lost tourism or recreation that wasn't being captured because of the impacts, lost businesses from businesses that don't return. So that's the lack of potential future revenue, which then impacts wealth generation for that community. Chronic runoff is often more devastating, and I would say often overlooked. The interesting thing, there's obviously more attention to the bigger disasters, the bigger floods, more media coverage. There's also more funding that's available to help businesses and homeowners and communities recover from those natural disasters. And it's actually less likely that positive soil quality practices or soil health practices would actually be able to mitigate the damages from major floods. So we weren't in our research about to say, if you plant cover crops, and there's a big hurricane, you're not going to have any damage. But looking at some of the mid-scale flooding that is very, very often, that came up time and time again in our conversations, and then also this chronic runoff from agricultural fields, that they don't rise to the major disaster declaration. They can often be more devastating. And part of that is because there's less funding if they don't meet that natural disaster declaration, and the impacts of mid-scale events are potentially more likely to be mitigated by improvements in soil health. So you'll see, once I talk about our recommendations, we're really, really interested in learning more about the impacts of the mid-scale events and this chronic runoff. Talked a bit about community collapse. The risk of community collapse is real. It's often understated. It is something that I think we need to be talking not just about the severity of events, but also the frequency, how often, especially some of the smaller flooding events, how often they happen, and what is the tie with potential community collapse. We know that lower resource communities suffer disproportionate impacts. This was something that came up in some of our conversations, especially related to some of the flooding impacts that we looked at. And I think if you can go back to that slide. So we looked at the lower resource communities and the impacts there. This is especially true for flood-prone regions. And this is related not only to the ability, the direct impacts on those communities, but also the ability for them to recover. And then the last finding was that we need funding for not just for funding is needed for prevention, not just more disaster recovery funds. One interesting idea that came up is looking at FEMA's community rating system, and could we better utilize that to incentivize improved soil health practices as actually a means of flood prevention. So if you go to the next slide, I think this is one of my last slides to walk through. So these are just some of the ideas that we had in terms of next steps and recommendations. Again, talked a lot about, we just need to know more about the impacts of some of these smaller and mid-scale flooding events, and especially the chronic water quality issues. Very difficult to disaggregate and parse the data out when we looked at some of the flood data on what types of flood were covered, what weren't covered. We need more research. We need more case studies looking at the local level and really understanding the on-the-ground impact, and really having concrete actions, at the state level for folks that are on the front lines of disaster response to see what the impacts are in their communities. We need new models to be able to quantify all these disparate costs. Original charge of developing this cost-benefit analysis proved to be very difficult. So we need new ways of thinking about this and new ways of pulling together all of the different data and all of the different variables at all the different scales. We need a better and more in-depth analysis of some of the racial equity impacts. There's been some research done looking at environmental justice issues and access to clean water, but really looking at kind of this flooding, the flooding disparities, especially looking at some of the more chronic issues in smaller towns and rural municipalities. It came up in our research, and we need to have a better understanding of that. Then the next one, convening a federal task force to coordinate across agencies. I hope we get to talk about this in the next session. It would basically be replicating the approach that we took here at the federal level. This could also be done at the state level as well, bringing together folks that are working on disaster assistance and recovery, flood prevention, climate change, soil health, and racial equity, to really understand and coordinate who's doing what and who needs to be involved in which conversation. And then the last one is, we just need to know more. There needs to be better data. There needs to be more research. It needs to be informed by communities, and especially rural communities that are living through a lot of the impacts that we found. And then obviously improve data collection over the longer term so that we understand what we're dealing with. I think the last slide, I will just say thank you. These were some of the other folks that helped me be able to pull all this together. So I think we'll open it up for questions. Thanks.
Thank you very much, Julie. That was, again, a marathon. I really appreciate your having tackled so much and brought so much to it. We have about 12 minutes for questions, and then we're going to have a break with the next session starting at the top of the hour. So let's, I'm going to ask first, Chris, if you have found any questions in the Q&A box.
Yeah, there's a couple. There's a couple here that may be able to be addressed. The report that Julie just told us about showed us the impacts of flooding and water contamination on communities across the country to some extent. And the question is specifically about the 2021 infrastructure bill. And is that, are the funds available through that able to address any of these community concerns that you were talking about in any kind of a meaningful way that you know of?
Oh, that's a really good question. I have not done a deep dive with the flood prevention lens on to see what could be used. My assumption, I mean, there was a lot of money for states. There was a lot of money for infrastructure. I think it certainly can be helpful for the some of the prevention. I honestly don't know how much of that funding is going to be going out the door in terms of flooding. And also for droughts, that was something else that we talked about but didn't dive into. So without speaking, I would say probably, but I'd need to look more.
Okay. Yeah, and another question that came in that had to do with funding. How important is the source of funding in dictating the kind of research that you can do in these areas? And this could be open to any of the panelists, probably.
My first reaction is, I think depending on where the funding comes from, it could certainly influence the type of research that's being done. I think primarily it's going to match the priorities of wherever the funding is coming from. So if it's coming from USDA, for example, the obvious tie to USDA priorities and to farmers. If it's coming from EPA, it's going to have more of a time, more of a priority on environmental issues. Philanthropic sector, corporate sector, it definitely can matter. It will reflect the priorities of whoever's providing the funding. And that's part of the reason we were interested in bringing folks together to share what are the common priorities and knowing this is not a single agency, single department issue.
Great. I have a question that I would love to present to all of the panelists, anyone who has an interest. And that is, as I looked at your list, Julie, a lot of the items of benefits from societal benefits are in the form of avoided costs. It's the avoided costs of repair. It's the avoided costs of cleaning up drinking water. It's the avoided costs of losing of community collapse and many of these others. And what I'm interested in is understanding is after you all have done your deep dives and have gotten a sense of what is and isn't out there, there are other sources of flooding than agricultural practices. How do we get some sense of how much we can attribute of those benefits, which is another way of saying the avoided costs, to soil health or the use of soil health? What does it take for us to get our hands around that? And this is also Dianna, and it's also Julian. Any of you who has an interest in taking that on?
Yeah, well, at the risk of sounding kind of like a broken record, I think that, that's the underpinning of the studies that we hoped to kind of call for in our work, is that, just as you said, Margaret, really being able to quantify how much of this was due to soil health. I think that to kind of reverse that, what I would say is that the knowledge, by and large, that's been developed in soil science, in geophysics, in spatial science, in climate. I mean, so much of what we know about the physical world, has looked at how things are now, and it's looked at things like, well, how does topography make a difference, or soil type, and so I guess what I would say is those of us studying soil health would say we don't quite have the tools to quantify the effects of soil health, and we think that it's underestimated. For the same reasons in that kind of simple example that I showed of, we just don't have the algorithms yet that show us the effect. So it may be that the effect in some cases is not large. I think that's great, to the Julie's point about, no, we're not going to stop, a hurricane with a cover crop, but we don't know yet. So I think it's those biophysical ties to really represent in models. And I can see scaling that up with a lot of the tools that Julian talked about.
Mm-hmm.
And I'll just jump. Oh.
Go ahead.
I appreciated Julie's recommendations. I mean, I agree with all of them. I don't know who's going to fund all that, but better data, sharing data across agencies. I think from the Climate Hub's perspective, we love breaking down silos, but that just takes time. And from the crop insurance laws perspective, working with RMA, it was like pulling teeth to get those data. And so I was just reading the paper. I noted that it was difficult to assess the costs of agricultural flooding because CBO couldn't get those data, right? So to what we're discussing, I think that from the Climate Hubs, what we've been able to do is try to get USDA to even share the data across the agencies, right? And so from there, can the Climate Hubs help you and everyone else kind of get those data, to help inform your models, help inform your tools, and so we can get at a better calculation of the benefits of soil health. And I think the hubs are starting to get there, but we're just one cross-agency organization. We could use help from other programs and other experts if they see a benefit to that. But to note that, the hubs have been trying to do that, getting better data, but it is difficult.
Yeah, thank you.
Yeah, and
There's a
the only
direct
thing,
league. I'm sorry.
yeah, the only thing that I would add to close up on that, and then if we have other questions, part of also the challenge that we ran into with this, and Margaret, I know we talked extensively about it, is there is so much variability depending on where you're looking. So if I'm looking at a specific watershed or a specific town or a specific region, there was so much variability that it was very difficult to come up with one analysis, one number, and I imagine, Dianna, like we had these same conversations of it's going to be different everywhere. And so how do we then capture that and reflect that? And we're just going to have to keep trying and really understand it's going to be different depending on the location.
I think we're going to go ahead. You have another question that has arisen, Chris?
There was one question related to that that you may have answered through that last question or that last answer, but do you have any information or data as it relates to where water is coming from urban area headwaters as compared to rural tributaries, coming from rural tributaries in these flooding situations?
Yeah, so our paper did not look at the source of funding. We were really looking at some of the costs and the impact. I think that it is something that came up in our discussions, and it kind of flowed between the two topics that both Dianna and I looked at. I think especially because we were less focused on a lot of the urban areas and really looking at some of the smaller towns and rural municipalities that were located in agricultural regions. I could make an assumption that more of the water was coming from agricultural runoff, but we didn't specifically look at the different sources of where the water came from, except from case studies that said it came from mostly ag runoff for the agricultural region.
Yeah, and I would echo that. I think, it wasn't largely the focus. I would say a piece behind that I think is good to keep in mind is what the economic drivers are of that land use. So for example, years ago, I was talking to farmers in Texas and they were like, we're not even going to have a soil health conversation when we're in Austin, and I'm going to get offered, 10 times what I could ever make farming to build a parking lot on this. And so, the piece when you get into urban environments, there's a lot that should be discussed about urban design and the physics there. But as well, the order of magnitude of the economics of urban systems is totally off the charts compared to, $52 an acre for changing crop practices. So they're related, but they're kind of different. It's a different beast.
Thank you. I am going to bring this really interesting conversation to a close. We couldn't have had 3 more interesting speakers, and I have really enjoyed working with you and just the thought that you brought into taking complexity and bringing it into some degree of understandability today. So thank you for that.